Okay, 10.2, finding arc measures. Starting off with the definition, a central angle of a circle is the angle formed by two radii that has a vertex at the center of the circle. So this central angle would be angle ACB. We have minor arcs, major arcs, and semicircle. A minor arc is less than 180 degrees. It's less than half a circle. A major arc is greater than 180 degrees. Uh-oh. And then a semicircle is equal to 180 degrees. Right? Remember that the whole circle adds up to 360. So if I told you that this one was 50, you would know that the other piece, this big piece there, would be, what would that be? 310. A major arc is always named with 3 points. So let me erase this for a second. This one has minor arc AB, that's talking about right there, and the arc is actually the edge of the circle. And then we have the major arc ADB. And they put that middle point in there, the D, that way we know that we have to go the long way around. All right. The measure of a minor arc is the measure of its central angle. The measure of the major arc is the difference of 360 in the measure of the related minor angle. And the measure of a semicircle is 180. That's kind of what I just said. Example 6. These are all supposed to be arcs. Find the measure of each arc in circle C. Segment AB is a diameter. Whenever we talk about arcs, you can kind of see it here, but we always list them with the two endpoints, if it's a minor arc, and then a little arc on top of it. So measure of arc BD, well, here it would be 45 degrees, right? There's its central angle. Its central angle is 45. Measure of arc BAD, measure of arc BAD would be this way around. Let me see if I can draw that a little bit nicer. This way around, which would be 360 minus 45, which would be 315. And then lastly, the measure of arc BDA would be this piece there, and that's a semicircle, so it's 180 degrees. Right? Anytime a diameter, right, it told me that a diameter was drawn in. Anytime that a diameter is drawn into a circle, it splits the circle in half. It splits it into two semicircles. Two arcs of the same circle are called adjacent arcs when they intersect at one point, right? So whenever they meet up with each other. 10.1, arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs, right? So if you have one arc and you split it up into two smaller arcs, then you can add those two up and you get the bigger one again. Here, find the measure of each arc. So this should have a little arc here, and we're talking about measure, so I'll put an M in front of it as well. Measure of arc. All right, starting off with XZ. Well, XZ is this piece right there. So that's going to be, what is that? 135 plus 40, which is 4, 5, 6, 7, 175 degrees. Measure of arc WZX is that piece there. So that's going to be 70 plus 135 plus 40. Let me erase this here. And whenever I type that in, I'll get 70 plus 135 plus 40, and I get 245 degrees. And lastly, we have arc WX. Well, that one's unlabeled, but it looks like it is 360 minus, I'll take away the other 3. So 70 minus 135 minus 40. So I'll say 360 minus 70 minus 135 minus 40, and I get 115. Alrighty. Congruent arcs. Congruent arcs have the same measure and come from congruent or the same circle. So congruent arcs have to have the same angle measure, and they have to have the same radius, right? If they're in the same circle, then obviously they have the same radius because it's the same circle. If they're in congruent circles, then congruent circles would have the same radius as well, right? So congruent arcs need to have the same measure. We'll say same angle, and radius. Equal measure and equal radius. 10.3, the congruent circles theorem. Two circles are congruent if and only if they have the same radius. Right? That should kind of make sense. 10.4, the congruent central angles theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Right? And that goes back to what we were saying up there. Oops. What were we talking about? Congruent central angles in the same arc are in congruent arcs, two minor arcs. So there's where it's talking about the arcs are congruent if and only if their corresponding angles are congruent and they were in congruent circles or the same circle. So it's saying the same thing in a little bit more wordy way. Here, tell whether the indicated arcs are congruent. Well, this one here, I need to put little arc symbols in there. Arc PQ is this one here, and arc RS is that one there. They both have a measure of 57 degrees, and they're coming from the same circle, so they are congruent. Next up, arc AB and arc FH. Well, AB has a 60-degree angle and a radius of 8. Arc FH is a 60-degree angle and a radius of 6. These are not congruent. Not congruent because the circles are not congruent, right? They are different. 10.5, all circles are similar, right? You could take any circle, and to get a different circle, you just shrink it or make it larger, right? You use dilation. And lastly, two arcs are called similar arcs if and only if they have the same measure. All right, that is it. What was probably the most important piece of this one? Probably doing a problem. Well, here, that's a good picture. Make sure that you have that picture. You know that minor arcs are less than 180, major arcs are greater than 180, and you also need to know how to name these. Make sure you know how to name them. Know that a major arc has 3 letters. A minor arc only needs 2. All right, that's all.